The title of the session is Service Discovery in a Mixed VM and Kubernetes-based Environments using Consul. And our speaker is Tomas Boros from mAdme Technologies.
Hello. Okay, cool. Thank you very much. Yes, so my name is Tomas. Today I'm going to talk about our journey, how we managed to migrate huge workloads from a VM-based environment to Kubernetes. And I also would like to talk about how Consul helped us to solve our challenges which we faced along this migration. First, let me tell you something about myself. I'm a sysadmin and a DevOps engineer. I did my PhD at this university, actually. And while I was doing my PhD, I also had a chance to live in the Netherlands. And I did some research on the 5G core, on media delivery with MPEG and MPEG-Dash on dynamic adaptive streaming, and also a little bit some research on content delivery networks. And at the moment, I'm working as a contractor for mAdme Technologies. The company is based in Dublin, in Ireland. I work fully remote. And at the same time, I'm also a consultant for Slovak Telecom and T-Mobile Czech Republic. And for them, I'm helping to manage and maintain their content delivery network on which the Magio Go is running. Just a nice little side note that currently the Magio Go is reaching almost a terabit in prime time, so it's quite growing quite big. But yes, today I'm going to talk about a little bit about what we did at mAdme Technologies. So mAdme Technologies is a software company that is providing a digital customer engagement and customer experience platform. Just to be clear, what is it? So what they do, they are building software for telco operators, and we are helping those telco operators to reach their customers using advertisement and some campaigns. And yeah, we are helping basically reach the right audience within these telco operators. Yeah, so I joined mAdme beginning of the last year. And my main goal basically was to move the workloads from virtual machines to Kubernetes. mAdme at the time was running on about more than 30 microservices. Those services were running on virtual machines, and all the virtual machines were provisioned with Chef. It was running pretty fine until something bad until something was going wrong. Since I was quite new in the company and I had not that many insights about the setup of other deployments and where individual services are running, for me personally, it was really hard. It was really hard to trace back any issues in the network or any issues in the service. So at that time, the only single source of truth was basically Chef. So let's say an identity service went down on the deployment. For me, it was really hard to trace back, like where the VM or where the service on which VM is running. So we kind of knew that we're going to need to improve this as well before we start the migration process. Yeah. So the obvious choice was Kubernetes, of course. And since we have quite a huge deployments, so one of our largest customer currently is Jio India, and we run a sharded deployment for them, and that deployment is running on over 500 VMs. So it was obvious that the migration won't happen from one day to another. So we knew that there will be a huge transition period which at this point we're going to have services running in VMs and also in Kubernetes as well. So we knew that we're going to need a service discovery. Lucky thing is that service discovery sort of mechanism is supported by most of the public and private clouds. So Azure, OpenStack, VMware, they all have one. The problem is our customers, when we are hosting the solution for the customer, we mostly host it on Azure, but unfortunately, we also have some customers who prefer to have their deployments on-premise, and they don't necessarily use Azure, but they might be using OpenStack on VMware. So we were looking for a solution that could fit all these environments. So yes, we started looking into options. So we all knew that Kubernetes does have a service discovery mechanism built in. It's using CoreDNS. So the CoreDNS inside this Kubernetes cluster has a Kubernetes plugin that connects to the Kubernetes API and pulls basically all the services and all the pod and all the definitions, and provides a DNS endpoint to the cluster, using which you can very easily target individual deployments and pods. So let's say if you have a service running called identity in namespace Q&A, then you can simply find this endpoint on the domain name identity.qna.svc.cluster.local. If you have if you're using the default domain name, that's what Kubernetes is using, or you can use whatever domain name you configure. But unfortunately, so this is working great. So even if you scale up or scale down the deployment, you will always use the same identity, so you won't have to do any modifications to the applications that are talking with this service. Unfortunately, such service discovery is not present for virtual machines, so we needed to implement or deploy something that was out there. So we started looking into options, what we could deploy, and basically we came across Consul, and yeah, we gave it a try, why not? So we tested it, we installed it on a few VMs, we installed the server layer in Kubernetes already, and basically we registered some services, and we just found out that it basically works brilliantly, and it more or less covered all the use cases we needed from the service discovery protocol. And yes, we never really considered any alternatives, since we didn't really need it to consider. Okay, so how did we deploy Consul? You have to deploy at least 3 servers of Consul. So Consul consists of two different components. One of them is the server layer, basically that stores the information. It has a persistent data as well, and you can install as many Consul agents running as clients, as many as you want, and you can join them together. So in order to achieve high availability, you need to deploy at least 3 Consul nodes. And the Consul server is using Raft protocol to achieve consensus. So, and then you can deploy an unlimited number of Consul clients that you can join into this cluster. And this cluster is using Surf protocol for information propagation, as doing in a gossip way. So the server part is strongly consistent. That means each and every read from whichever node is always basically up to date. So the database is consistent across all the Consul servers. There can be some slight little inconsistencies in case there is a leader election going on, for instance, but it's very, very unlikely. It only happens when something goes wrong in the network, for instance. And the clients are basically eventually consistent. So imagine one of those agents that's running on a VM, starts up, registers a service, and then once the service is registered, this information is propagated to a set of nodes into network, and that set of nodes propagates this information to another set of nodes, and so on, until the information is propagated through the whole Consul cluster. That's why it's eventual, but actually it's really, really fast. So I've included the URL on the bottom. Well, you should check it out. It's an article from Consul, from HashiCorp itself, and they were testing how fast this protocol is on a huge scale. So they were trying to measure how fast they were managed to propagate some information using Consul over 10,000 nodes, and so they were able to propagate the information throughout this cluster always under 1 second, so which is, I think, quite brilliant for that scale. Okay, so how does it work? Consul basically is a service discovery. I mean, Consul has more features than that. Today I'm talking most about the service discovery. It has 2 endpoints that are actively used. It has an HTTP API and also a DNS endpoint. It also has a gRPC endpoint, but this is not really enabled default, and we were not using that either. And how does it work? You basically start an agent, and you can register a service to this agent You can define that service using an HTTP API, or you can define the service using a configuration file, either in JSON or HCL. That's a kind of a configuration language by Consul. Yeah, this is how does it look like. So you have the server layer up and running in a Kubernetes cluster. And what we did, we basically installed this Consul agent on each and every VM that we're running inside the same network. And once the agent is connected to the Consul cluster, it can start registering services. So for instance, there is a PostgreSQL VM running, which is registering the PostgreSQL service. Once it's registered, this information is propagated, and at this point, this service basically becomes this. On the right side, you can see an example how does a service definition looks like. So it's very, very simple. You just define an ID, a name, and you have to define the port on which this service is running, and you can add some tags or metadata. You don't necessarily have to, but yes, you can include some. And on the left side, there is this console UI. This is, once you do that, you can see that there is a service registered, and that service is currently running on node azure.qa.db.sh0101, and the service name is Postgres main master. So, oops, sorry. Okay, so once you have that, at this point, this service becomes available for the rest of the this DNS endpoint becomes available for the rest of the network. So you can query this service by the node name or by the service name .service.domain. So I'm going to show you a really quick demo. How does it look like? For our configuration, you can choose what domain you want to use for this console setup. In our case, we are using the domain name .mAdme, as it was an internal network. So let me open the console UI. This is how does it look like. So this is the server I mentioned that is registered with the console cluster. And if you click on the service instances, you will see all the services that are registered with this node. And this is the database, the Postgres SQL service that I mentioned is running here. So if you want to find out on what IP this service is running, you can basically do a dig. Is it readable? Yeah, okay. Do a dig to Postgres main master.service.mAdme, and basically you will get back an IP address, and well, basically tells you the IP address where this service is running. So fairly easy, very easy. But yes, from a service discovery endpoint service, I would expect that I only get endpoints that are currently up and running, just the same way as Kubernetes does it, using health checks. So Consul also has some health check capabilities. It has a lot more health check types than Kubernetes is, because you are basically running on a VM. So except for TCP or UDP or HTTP or gRPC, you can also define health checks for Docker services. You can check if there is a certain Docker image running. You can check if there is a systemd service is running. You can even run custom scripts. And there is this nice detail type of health check where it opens an HTTP endpoint, which you have to periodically send a request to for the service to respond that if it's being alive or not. And yeah, so on the right side you will see a modified service definition where you can simply create the service check, and you can have multiple service checks, not just a single one. So it's quite cool. Okay, yeah. So, but this is cool. We have Consul running, but we also needed to somehow make sure that we can discover these services running on this .mAdme domain from inside the Kubernetes cluster. So what we did, we had to do some certain modifications to our configuration, to our DNS configuration on the Consul cluster. So probably most of you, it's not necessarily a requirement, but hopefully most of you are using also a node local DNS in your Kubernetes cluster, which role is basically to cache DNS queries just to offload a little bit the CoreDNS endpoint. So what we basically did, we modified the config map of this deployment, and we included the .mAdme, we included the .mAdme configuration domain, and we set this endpoint to forward the request to the 10.33.16.39, whatever IP, where basically the Consul DNS endpoint is running. So this way, at this point, we were able to discover domain names running on .mAdme domain. And yeah, and for everything else, we still queried CoreDNS running in Kubernetes, or we queried the upstream DNS, which was configured by the ACP. Okay, so at this point, we could resolve domains from the Consul cluster from Kubernetes, and we wanted to be able to do the same on our VM environment as well. So where we just simply edited the network manager, and we enabled the DNS mask process, which is also a local DNS cache basically, and we added an entry point for the .mAdme domain. And for this domain, the requests are forwarded to the Consul agent running locally on port 8600. This is the default DNS endpoint port for Consul. So basically, this way we were now able to discover these domains without doing any further modifications. And yeah, so we also wanted to able to discover services on VMs that were running inside the Kubernetes cluster. And for that, there is this nice tool called K8s sync. It's also from HashiCorp. And you can install this small piece of software alongside the Consul installation. And what it does, it basically synchronizes all your service definitions inside the Kubernetes cluster and exposes them to Consul, so they become available. These services, as you can see on the Consul UI, are not editable. You cannot edit it. And they have a tag K8s, and it says that it's registered via Kubernetes. So if you try to resolve a domain name, for instance, here I'm trying to resolve the IP address of the Ingress controller, which is exposed internally on the load balancer, it will basically return the IP address of the load balancer where the service is running. Okay, so at this point, yes, we were able to discover all the services running inside Kubernetes, outside Kubernetes, and we interconnected these two worlds using Consul, and we were able to resolve those domains from inside pods and from a VM as well. So I'm going to do a really quick demo on how do health checks work. Let me show you quickly this endpoint. So yeah, so these are basically the services that are exposed from the Kubernetes towards the Consul. And let me try Promptail. Promptail is a little log gathering service. I hope most of you probably know it. So if you want to find out where Promptail is running on which VMs, you can do a dig promptail.service.mAdme. Service.mAdme. It returns me the list of the VMs where this service is running. So as I mentioned, this service also has a health check configured. I'm currently running on 172.180.9, which is included in this list. So if I stop this service for a while, I will see that within a few seconds, the health check will fail. This information will get propagated with this GOSI protocol, and I'll immediately notice that there is something wrong, that this service is down. So if I try to query this endpoint again, that IP address won't be present anymore. So the DNS endpoint is automatically updated, and it's and yes, as you can see, the TTL on these responses are set to 0. So your clients, your local DNS cache won't be caching those entries. So a nice cool feature is that you can also, of course, request SRV records, and the SRV records won't return you just an IP address, but it also returns you the port where it is basically running. And you can also specify weights and priorities for the SRV records. So just by using Consul, you can enable a very easy, very simple load balancing mechanism, just on the DNS level without having to deploy any kind of fancy AJ proxy or whatever you'd use as a load balancer. Okay, yeah, let me start Promptail here because I will be getting notifications. Yeah, so if I start in a few seconds, it just comes back alive and everything goes back to normal. Yeah, there you go. Okay, so at the next point, we wanted to. So since we were migrating away from VMs to Kubernetes, we already had an ingress controller, ingress controller deployed on a Kubernetes cluster, and we wanted to be able to target some services running on VMs through this ingress controller, because yeah, we wanted to get rid of the application layer gateways. Why would we use them if we don't really use them anymore, if we eventually migrate to Kubernetes anyways? So I previously mentioned that this K8s sync is synchronizing services from the Kubernetes cluster into Consul, but it does it the other way around as well. So I'm going to show this is going to be more understandable. So in this situation, the K8s syncs basically picks up all the services that are registered by the agents. It creates a service definition into Kubernetes, and all you have to do is it's enough if you just create basically an ingress manifest for this service, and this way you can achieve a very easy reverse proxy mechanism using the ingress controller. So basically what happens if a request is coming in from outside through a public IP to your ingress, it will get proxied. The request gets proxied to the service running on a VM, not inside the Kubernetes cluster. And yeah, one little side note, this service that is imported using K8s sync is marked as type external name. So, and yes, since Consul itself has service checks built in, you don't have to care about any health and any service checks, any health checks in Kubernetes. So this domain will take care of that you will always be directed to an endpoint that is always open and live. Okay, next cool feature. We previously were monitoring our Kubernetes, our virtual machine-based environment with the same Grafana, Prometheus, and Alert Manager stack. And eventually we deployed this Prometheus stack on Kubernetes as well. So we wanted to get rid of the old VM deployment. And yeah, we were looking into mechanism, how can we basically include those targets that were running on the VMs as well. And since we have Consul, we hoped that it somehow would be possible. And luckily, Prometheus has a Consul plugin. But basically what it does, we added this scrape config into the Prometheus configuration, where you have to define the server name, where the Consul cluster is running, and you have to specify which data center to pull. And we also defined a tag matrix. So basically what it does, it pulls out all the services that are running in Consul, and will filter out those services that have a tag set to metrics. And if it found any of those services, it included those as a scrape target and start scraping those endpoints. Yeah, very easy. This is how it looks like. Yes, so if I go back to my service catalog, and now I search for services that have the tag metrics, you see that these are the endpoints basically, which are marked as metrics. They have a tag metric, and we are storing some information in the metadata. And with Prometheus, we can, if you open the service discovery page, you see all the endpoints that are discovered, and we can see that we have this Consul scrape config set here. And basically, these are the endpoints that were discovered using the Consul endpoint. And with some reliable configs, we made sure that the labels are right, so we can use the standard Grafana dashboards that are basically built in with the Prometheus operator, the Prometheus stack. So if I open for instance, the page for the Graph dashboard for node exporters, I can immediately see that all my VMs basically got included in those metrics. Yeah, okay, so that's about monitoring. So basically at this point, we were more or less able to migrate every supporting services into Kubernetes. So we were quite happy. And yes, there are still some deployments at the moment which are where the migration is ongoing. But yes, we have already a few customers running fully in Kubernetes now. So we are quite happy with the results. And as my last slide, I would like to talk about some additional feature that Consul has, but we don't necessarily use by ourselves. So additionally, Consul also provides a distributed key value store. We use the key value store, for instance, to store Ansible inventories. So we have a dynamic Python script that basically pulls this inventory every time we run Terraform. So the dynamic inventory is generated with Terraform. So when we do changes into Terraform, they get automatically reflected into the key value store, and then we can pull that and run Ansible based on this environment, based on this inventory. It also has a distributed locking mechanism. It can be a backend for many HashiCorp solutions like Vault, Nomad, or Terraform. At the same time, it also provides a full service mesh. We don't use that, but it's really cool. It can inject invoice sidecars to your workloads and creates MTLS-based encrypted connections. It has a gateway capability using which you can interconnect multiple Kubernetes into each other and use the envoy the same way, basically to establish connections between workloads running in the different environments. And the last piece of software I really like, this is called Consul template plus Consul KV sync. Consul KV sync is a very small piece of software that can pull your Git repository, synchronize the content of your repository into Consul key value store. And the Consul template basically is a small little daemon that connects to your key value store or your HashiCorp Vault. And it is watching changes, if there are any changes to this key value store. And if there is a change, it is going to render a template, and it can run a script or whatever you want it to run it. And so it could be a very nice use case if you want to trigger, for instance, if you want to trigger config rebuild and re-rendering for certain applications like nginx. So it can be a very nice automation tool if you are still running some workloads in a VM world. Okay, so quick summary. I don't think it's really important now, and that would be it. So thank you.
Perfect. Thank you very much. So far, we haven't got any questions. So if you have any questions for the speaker, please use the Slido. Going once, going twice. If that's the case, you can always find the speaker after the talk and talk in person. That's always an option.